Hello and welcome to this video on how it is that bonsai wire is made. Whether it is copper or aluminium, a wire is an essential for bonsai. Despite how ubiquitous it is, the production of wire is both taken for granted, but also, thankfully, mostly the same between each of the metals. The starting process begins with the creation of rods, or in some cases a billet, but let's work on the basis of the simplified version for now. These rods are larger and thicker than can ever be used for bonsai. You can insert whatever joke you particularly want regarding the use of the word rod. The reason that these exist is simply to be used as stock from which you'll extrude or draw out your usable bonsai wire. To turn the rods into wire, you must draw it out. The rod itself needs to be stretched and pulled. This does two things. First of all, it makes it thinner, but it also makes it longer. It's done using a machine called a wire drawing machine, at least in modern terms. In older terms you would have done this manually and, well, that's a far more difficult task. The machine makes it much easier by pulling the metal rod through a series of small holes. This is done in a synthetic diamond die, the structure in which the hole is basically a giant stamp, for lack of a better word. Each time the wire passes through the hole in its stamp, it's made thinner and thinner, the diameter gets smaller, and it also, as mentioned, it gets longer. This does however lead to one particular point though. The wire itself, to a certain extent, it gets compressed, making it stronger but also more brittle. This is especially important when we're talking about very thin wires, because they are both easier to work with because thin wire, but also it to a certain extent makes them stronger and prevents them from breaking on you. If you're making, say, braided wire for a construction site or some other large structural work, they need to be made this way so that they're strong enough to be made into a cable. In order to ensure that the die itself has both longevity and you get a usable product, it has to be constantly lubricated and cooled. Now, the reason you need to increase the longevity of the die is simply they're expensive, being made from synthetic diamond and all that, but also it prevents the wire from overheating. If the wire gets too hot while being passed through the die, it will inevitably break. The copper itself will continue to be heated before it goes into the block, or the die in this case, and the reason for that is that it needs to be at least somewhat malleable or bendable. This allows the machine to push it through. That flexibility means it can also be pulled and formed into a long, thin strand. You need to achieve the right temperature for either copper or aluminium, even if you're using theoretically the same equipment. Temperatures will vary between them. At the same time, you also need to only push them through or pull them through at a particular speed, again for the same basic reason. Although they are heated up to a certain point, if you pull them too quickly to draw them out too fast, they will snap, just like pulling a string too quickly. Or, for example, fishing line. If a fish pulls too hard and you pull too hard in turn, the line will snap and you'll lose your fish. In this case, losing wire inside the die can actually be a real pain, simply because you now need to clear out the die, hope it can be salvaged, and then keep pushing wire through again. As with anyone who has experience with bonsai will know, this process is also going to lead to a second problem: work hardening the metal. That is, as it passes through the die, and even though it's coming through at least somewhat warm and cooling down, the fact that you're working it this way leads to it becoming harder, and that makes it harder to bend, and because you can't bend it, you can't apply it to your bonsai or bend it onto your trees. To solve that, the wire needs to be annealed. If you don't do this, the wire becomes extremely brittle and will break in the worst case scenario. In the best case scenario, it will just be incredibly hard and you can't use it. Both of these are very undesirable. Annealing is reasonably straightforward. The wires are heated, and they're heated up to a temperature wherein they don't get quite hot enough to melt, but hot enough that they are warm. They're then allowed to cool down gradually and slowly. This leads to a flexible and, to a certain extent, easier to use wire. The critical part is that you want to make sure they don't get so hot as to melt, but also not so hot and not exposed to oxygen. Oxygen will lead to an oxide layer forming, especially on copper. Aluminium, it's slightly different, but the copper it's more obvious with because you'll wind up with a very greenish tint on the outside. One way to get around this is the use of, say, noble gases inside the area where it's being worked on. The whole process is otherwise called recrystallization, and To be clear about it, although strictly speaking you don't need to worry about oxidation for small-scale wire production, on a larger scale it's much easier to avoid it. In some cases, it may be necessary to anneal wire multiple times throughout the drawing process, and that's because the work hardening prevents you from running it through a die again because it's just too hard. It doesn't want to pass through and get shrunk down to a more usable size, so you anneal the wire before drawing it again, especially if you're going from a very large gauge to a particularly small gauge. Arguably, the one reason why we see a solid wire used for bonsai, whether we are talking about aluminium or copper, is simply that it's cheaper to manufacture. Producing not only the larger number of very thin strands of wire, for example, if you have multiple gauge for electricity, and you have, say, 1mm wire, and you have 8, 10, 12, or however many strands all wrapped up together to create that as a functional wire for electricity, it's not really needed for bonsai. Theoretically, the two will work, but it's not as practical. And so, because you don't necessarily need that, you can get away with just making one solid piece of wire and passing it through only up until the size you need, rather than adding together smaller strands. The other point is that, to a certain extent, you don't need to worry about flexibility. The reality is that solid wire is not as flexible as stranded wire, but you only apply it once, so as long as you're not particularly careless, you don't need to worry about it having that particular issue. The advantage to doing this, other than what we've mentioned, is that, technically speaking, it has greater mechanical ruggedness. That is, although it is, let's say, less technically made, structurally it is that much more solid. It's not going to have exposed surfaces. For example, the multiple individual surfaces of each individual strand in a stranded wire that could be affected by things like oxygen, corrosives, tree sap, and so on. All these things which can occur in the environment when you're making a bonsai that could negatively affect its ability to do its job. This, let's say, process is also why you can't really remake bonsai wire, or at least not in practical terms. In theory, with some work you can recast wire, but it is a high effort, low reward process unless done on a reasonably large scale. And simply put, being able to, say, melt down the wire, cast it into an ingot or a rather large rod, and then pass it through your own dies of your own making, it's a lot of effort for very little reward. Alternatively though, you can take used bonsai wire, presuming you've taken off the tree in reasonably large sections, and you can practically and somewhat easily anneal the bonsai wire for reuse. Now, in the end, this is going to gradually lead to smaller and smaller sections of wire which will inevitably be thrown out, but you can prolong and reuse it and minimize the amount of new wire required, to some extent anyway. This is how you get the most common consumable product in bonsai as an art, the bonsai wire. And again, whether we are talking copper or aluminium, the same basic concepts apply. The only real difference is going to be temperature, and that's both relating to the annealing temperature and the drawing temperature. But otherwise, it's the same underlying concept. Thank you for watching this video. If you have found it interesting, consider liking, sharing, and subscribing. And please do post any comments, questions, or suggestions you have below.